Hey everybody, I hope you're all having a great day so far. I can't complain. Um, Nothing really special going on, so let's go ahead and get started. Today I'll be working more on the 2D lights kind of small break project where we're going to try to recreate a cool lighting system with 2D sprites where the lights will have a mask where they won't go through these I guess, well, why don't we just show? So, for example, here we have 4 lights, and ignore this multicolored texture in the background, that's just for testing. But when we move the red light here, you can see it kind of cuts itself out around the platform. And that's kind of the way we want the system to work. Obviously, it's not perfect right now, because sometimes you can see the other side, but that's not really a big issue. The cool thing about this is that each light is also independent, and we've done that by creating this texture back here, which basically shows the shadows for each light, and we encode the shadow mask for each light in a different channel of this texture. So like this red light is on the red channel, and blue, green, and alpha. And you can kind of see here like the blue light, the shadows are here in the yellow part because that's the absence of the color blue, and vice versa for all the others. So yeah, I think and so the problem we were having last time is, one reason that we're trying to do this is we want to minimize the number of draw batches here. And right now, each light has its own draw batch, which is not what we want. And the reason it does that is because, let me pull up code here, we have to set the color in the material, and every time you set something in a render material, it basically has to create another batch here. And the way we can get around that, thankfully, if we go into our shader, we just want this one. Or wait, which shader is this using? Select channel mask. Okay, I had the right one. So right now, basically, we use this variable, channel select, to well, I got a little fancy here using the dot product, but basically whatever value in here is not 0 is the channel that the mask will use. And if you're not familiar with the dot product with vectors, all it does is basically multiply the corresponding components of each vector and then add all those results together. So it's red times red plus blue times blue plus green times green plus alpha times alpha. And that works out perfect because the channel select, all the components are 0 except for the one that we actually want to mask on the sprite. But since we set it here in the properties of the shader, every time we have to change this channel select, it will create a new draw call, which will not be good for what we're trying to do. That will slow down the performance. Let's see. I forgot to set or update my title, so let me type that out real quick. So what we want to do is use, well, basically we want to send the information in this mesh data, and if we do that, it will just be streamed onto the GPU, and it won't create another draw batch. So basically, I have a page up here that I got. So we'll have float for color, and the syntax here is a little strange. Basically, you have the name of the variable in here, and then this is kind of like a type, but it's more like what data is going to be held in this variable. So the vertex is pretty obvious. It'll have the position data. This text chord 0 is basically one set of UVs. I think you can have up to 4 text chords, maybe even more. And then, but we'll just use this color. So the thing about UVs is it's just float 2, but the color is a float 4, which will work well for us. And you gotta do the same thing here. And the reason this changes to, I'm not sure exactly what SV stands for, but this basically means the vertex in screen space instead of the vertex in local, the object space. And okay, so yeah, we won't need this channel select at all. So I'll just go ahead and get rid of it. And all we have to do is just copy the color. So output equals input. And so instead of using a channel select, we'll actually just use this i.color to multiply with the mask. Okay, and also, yeah, this is just kind of our hacky way to get correct UVs for the mask. We'll have to, well, we'll fix this soon. And that's just because the mask texture is for the whole screen and not just for the sprite only, which we will get to soon. Alright. So now what I need to do is in this light mesh creator, we'll need to also set the colors here. And the colors will basically be this channel select. So mesh colors. And just like UVs, there's one color for each vertex, and since we have 4 vertices, we have to have a 4 index array. You might be thinking that, why do we have to do this? Because we're actually going to send more data than just having to set it once. Well, I don't have a great answer for you besides that, just that that's how it works. If you send data through the mesh, then it doesn't trigger another draw call, but if you send it through the material, then you'll have to trigger another draw batch, or like interchangeable draw call and draw batch, the same thing. And unfortunately, in the mesh, there's only specific values you can send, so you need to, but you can use them intelligently. Yeah, so you can have 4 sets of UVs. I was just curious about that. I think this will work right away now. Okay, so if I move this, okay, yeah. And if we look at the stats, we can see now there's 9 batches. I guess let's check out the other lights just to make sure everything seems good. Okay, and we can check to make sure these lights aren't affecting the batches, because if we disable them, the batches should stay the same number. And it is. Alright, so again, the number, I guess we have 1 batch for all the lights, a batch for the normal sprites, and a batch for this test texture, gosh, I can't talk. And then there'll be 1 batch for each shadow render, and then another batch to blit those textures together. So that's 5, 6, 7. So that gets rid of 5 like I thought. I'm just trying to figure out where they all are. That's 1, and then the lights. Oh right, for some reason these sprites are taking two draw calls, and I'm not really sure why, because okay, so interesting that actually the sprites are only taking one. Then what is this? I guess there's just one draw call for the camera background or something. It's a bit weird, but okay, well that's good to keep in mind. I wonder if I cover this whole screen with a sprite, or the whole background with a sprite, if there'd still be a draw call. But that's okay, so now we know where they're all coming from anyway. Okay, so did that. So now there's a couple more things we need to do. We can render a shadow mesh to one section of a texture. But I think I'm actually going to do this part next, which is kind of two things. Basically, we need to have the mask just not cover the whole screen. Which should be pretty simple. Right now the world bounds. So how we should actually, we need to change, I guess, the way the shadows generate, because right now we can actually see the shadow meshes in the editor, these white parts. So right now they collide with the edge of the screen, but actually we only ever need to try and generate meshes if they're inside this, the extents of the light sprite. And that's also the size of the resulting texture, which I think they're 128. Actually, I guess I should look it up. Sprite program always takes a little bit to open. Oh, right here it says 128 by 128. So good to see. So basically, whenever we create the shadow mesh, we should just create it in the middle here, as if, like, and transpose everything to the center of the sprite. I guess one other thing is well, let's not even worry about that now, but obviously we won't need to create any meshes for shadows that are outside of that range, although I don't think it will end up affecting creating that texture at all for the moment. So what is it, the shadow mesh creator? Okay, so first of all, since I'm still using the physics raycast, I need to resize the bounds here. So we want 128 by 128. So that's everything. That's 4 wide, so it should be 2. Okay, so now we see the new size of the shadow texture, and it's the same as our light, which I guess it's hard to see if the game's not playing. I'm in play right now, but so yeah, so now it's here, and we can also see that the code's not working right this moment because yeah, everything's just not used to the new system. I wonder why it's all going to 0 right now, actually. But I guess I'll find that out soon. Probably because it never collides. So yeah, we'll need to fix that. Okay, so this is the point. So it returns a hit point and a hit normal. We don't actually use the normal yet because that's is for later on to figure out which wall the light actually hits. We might need to do that because with this smaller texture, this problem will become much bigger. Okay, so I guess for now, if hit collider is null, we'll just set a point. It's basically at the max distance, which right now it's 28, but I can shorten this quite a lot now. Let's make a constant here. So basically what I need to do is deviate diagonally from that box, so that's by Pythagorean theorem square root, so 2 times 2 plus 2 times, oh wait, that was 4 times 4. Okay, so I don't know if it'll let me do this. As a constant, so I'll just do static read only, square root, which I could obviously figure that out, but this will make things easier. Okay, so now this point can just be, I guess I'll need this direction vector if I'm going to do something like this. Just be a maximal, at the maximum raycast distance in the given direction. So we can pretend it hits some imaginary collider out there. And if I do that, then I think everything won't go to the middle point, at least. Oh no, it still does because I return false. So we'll just always return true. Or actually, I don't think I don't even use that return value. Oh, because I'm setting it in the hit point, I need to set it in the return variable, not the raycast collision or the raycast results. Okay, so now it's a bit buggy. Oh, what am I moving around? Oh, the world bounds. So I'm going to move red. Okay, so, oh yeah, so the only lantern that we can actually see in the editor is the one that was last created, which is the alpha, and it's still... Okay, I don't know why that's scrolling in on itself. Interesting. But anyway, let's not worry about it too much until we actually get all this working. Okay, so really what we need to do is we just need to shift all the segments by the light position. So light offset data lights. And I think I can just just shift it here. Oh, it's because these are vector 3s. And if you try and add a vector 3 and a vector 2, Unity complains because it doesn't know if you want the final result to be a vector 2 or a vector 3. but it'll work fine like this, and I think that's really all I have to do. Things are just going to be kind of strange though. Until I get the whole system working, I think it's going to be hard to test anything. Yeah, and I might need to convert the shadow drawing away from the physics system. Or I just need to decide for sure, because we're going to need some way to figure out if a point is inside or outside the collider, I think. And then there's some things like a segment could be partially in the texture area, which will be a little strange. Actually, now that I think about it, I could just leave the world bounds how it was before, but then the camera only renders this center part towards the texture. That way I wouldn't have to change anything besides this shifting everything to the middle. Although I guess then I'd have to also shift the world bounds, but that's not a huge problem. Okay. Well, I don't know, maybe I'll keep that in the back of my head. I'm not sure which would be easier. I think actually in terms of performance, shifting the world bounds would be bad because the edge collider wouldn't be able to stay as a static collider, then I'd have to do something else. But anyway, I'm still... I don't know if using the physics system for this is really the best idea, but... Oh yeah, especially because... Yeah, one of the reasons why I was using it is because these colliders, I thought we might have to also know if we hit another collider, but if we're shifting everything to the middle, that's just not an issue anymore. Okay. Let's just move on and we'll come back to that. So one other thing we need to do is on the light mask manager. When we create all these textures, we need to change the size to be 128 by 128. So let's see what happens with that. Okay, so it's still a little weird because the camera is still rendering the whole screen. So let's see, how did I do that? So I think the size would be 2. Let's turn that on and we can see its camera. Which that matches up with the world bounds, except it's still widescreen. So isn't there... So we still want to be orthographic. How do I guess I can't set the aspect ratio from here? Oh yeah, this, we don't need that anymore, actually. Am I just missing something? I guess it just always matches the display. Okay, so I guess I'll have to do it in code. I'll just set that right here. So data, shadow camera, aspect is just 1. Okay, so let's see what happens now when I play. Hopefully this will shrink. Okay, yeah, it does shrink to a box. But I think it's probably still trying to render the whole screen. So right now it's over the alpha. Well, no, actually, it would just... Yeah, it's only rendering the part of the world that's in this box. So, yeah, that's working okay. And I guess I can test that by moving... Oops, wrong thing. If I move the alpha light... Oh, wait, this is just all messed up, isn't it? Yeah, when I do that, we can see it also is rendered on the camera. Okay, so obviously the meshes are still tied to the collider even though I offset them. That's the only point we ever get a position is here. So I'm a little surprised. Yeah, I guess I can turn this camera off now. Yeah, because I'm surprised that the shadow meshes, oops, are still sticking onto the colliders, or maybe they're not, but it's just so weird. Because really, when I have this here, these colliders should be like transposed up here as if the light is still in the middle of the screen, but they're not doing that. Should it? Maybe this should be negative. Or did I think it might be better if I put it right here. Okay, so now it is moving. Yeah, we can see it's still creating the meshes we expect, although it's a bit weird, isn't it? It's like the position is flipped because it's going inwards instead of outwards. Oh, that's probably because it still uses, we just use the plain light position, but actually we need to use, I guess now, instead of using the position here, it's just to, okay, so that's interesting. So the light is always at 0, 0, so really the direction is just this point normalized. Yeah, because the point is outwards from the center. Okay, so now that's looking better. I think that there's still some weirdness. Oh yeah, because we get it right here and then it hits both sides of the collider. But shouldn't this be in the middle? Okay. Okay, so I think what I'm actually gonna do. Oh, 1 second, my cat wants out of my room again. I'll be right back. Okay, thank you for being patient. So I think what I'll do now is I just won't even do a raycast, and I'll basically just extend the point as far out as it will go. Really that will be fine. I mean, yeah, I think that'll be just okay for now. So I'll comment this out in case we come back to it at a later point. What's wrong with this? Oh, I need to set these out. So hit point is just direction times raycast distance, and I don't care about the normal right now. So now we won't have to worry about raycasts. Although, okay, so obviously there still is some problems. I guess I could just extend the raycast distance for now to try and get rid of that error. Okay, so let's not be fancy. I'll just set it to 30. So yeah, this is not very efficient at all, but so now it at least covers up the whole mask usually. You can see it better on the play screen. Okay, so if I move one of the other lights close to a collider, yeah, we should start getting other colors on the texture. Cool. And now I think we can get rid of this, and if I just say I.UV, since the mask texture and the light texture are the same size, they can use the same UVs. And I think everything will just work. Cool, and it does. Actually, works even a bit better than before because we don't start to get problems until you get really close to the platform. Although, interestingly, the lines are more fuzzy now, I guess because the texture is smaller, but I'm actually not sure. Maybe because I didn't set the texture to be point sampled. So here in the manager, I think if I set this texture, is it filter mode? Yeah, we want it to be point, and I think these light textures will all be like that now as well, and so we'll get sharper borders. Yeah, that looks much better. And again, I think it will work with all the lights. Let's move green and red. It's hard to tell. Okay, so now we've got it to work. Let's actually look at the profiling and see how bad the rendering is now. Okay, so it still takes up a big chunk. It doesn't seem like making a smaller texture made things too much smaller, or too much faster. So yeah, the light manager update, the graphics blit. Okay, so this graphics blit actually takes barely any time at all. And that's just the shader that combines all the textures together. Oops. Camera render. Okay, so that's interesting. It's actually drawing these meshes, probably because they're so big, so maybe the performance will get a lot better when we call out the meshes we don't need because they're completely outside this box and not make such huge triangles. Yeah, so culling takes quite a bit of time because it's trying to figure out which triangles are outside. Or actually, I don't even know if it can go on the vertex level. It might have to go on the pixel level, but... So if we do that ourselves before we render, then we won't have to test twice, basically. But I'm really happy that this graphics split barely takes any time at all. Because we might have to call that a few times, depending on how many lights we want to have in the scene. So this camera render, well, it's called 4 times, so that means each time is about 2.5% of a frame. So yeah, that's gonna add up a lot when we have to render it every time for each light. So yeah, it's rendering opaque. Actually, there shouldn't be any transparent. Maybe I can speed that up a little bit if I take out the transparent. So what is it? The shadow mask creator. Actually, no, I don't think I even use this. Oh yeah, I don't actually use a shader. Okay, so maybe it's time I make my own shader for the shadow cutout, because it seems like that might be taking up some time. Okay, so let's do that now. Oops, don't need that window open. This creator, I don't think I use. I don't want to just delete it though, because I might use it somewhere, but yeah, this is the shader I did to combine, and then this is the final one. Okay, so hopefully that won't mess up anything. Let's just make sure. Okay, no, so it's all good. Yeah, that was for some other thing I was testing, might as well get rid of it. So I'll have another unlit shader, and this will just be, I guess I'll just call it white, because we'll just render white basically. So you don't even need a texture in here. No fog. And don't need UVs. So yeah, we just need the vertex. I don't really need the position here, but I think it still needs to be stored. And I just return fixed for 1, 1, 1, 1 for pure white. Okay, and render type opaque, and I want to get rid, ignore projector. maybe more things I can do. Yeah, we don't need Z writing because there's no alpha or anything. Okay. So now the shadow cutout material I can change to my new white. Let's see how that looks. Okay, so everything still works fine. I guess let's look at the profiler. Let's see if it's really gotten much faster. It looks about the same, to be honest. No, not that. Maybe it's slightly faster. Yeah, it still has this render transparent geometry. Which I don't really know why. I'm not familiar with the graphics pipeline that well. Maybe it's because I have this rendering path on. Let's just try that. I think the forward lighting is a little bit simpler. Oops, I don't want to change the camera. Well, everything still seems to work fine. No, it's about the same, okay. Yeah, I don't know why we still have this render transparent geometry, even though this shader basically says it has no transparent. So maybe I'll need to look into that. But yeah, I think just set this to forward, which I think is the fastest render path. Which is fine because the camera, I mean, all it's doing is rendering white meshes. It's really simple. We're still having really great frame rate, obviously. I mean, all this yellow is basically just the game idling to try and keep a normal frame rate. So I mean, I know I really don't need to worry about it at this point, but I want to try and support a whole lot of lights, and it will add up. Did I? No, it's about the same, isn't it? So yeah, I mean, definitely rendering the shadow meshes is the most expensive thing we're doing right now, because the blit takes basically nothing. And well, rendering the actual world takes about the same time as rendering each time for the shadow mesh, which is a little bit surprising to me. Maybe just because it's a little slower to draw to a render texture, I don't know. Because here it says camera render, so that's about 3% each time. And then this camera render, yeah, it's not that much different, but yeah, this camera render is what renders the actual screen, so it has to do our mask shader, which is a little more complicated. Okay, but anyway, no use trying to optimize too much at this point until we actually get the entire system completed. Okay, so I guess our next step, so we did that, is we want to try and support more lights by splitting our texture up into 4 quadrants at this point. And to do that, well, we'll need to create more shadow meshes and more lights. I think I might just create the lights programmatically now, because I don't want to have to sit here and make 16. So let's create a prefab out of this one. Okay, we don't care so much about what channel it has now. Although I guess I will need to set this programmatically. Okay, so yeah, let's create a new script here. I guess let's just call it a lantern. And we'll need to use mono behavior, so I better type using Unity engine. So lantern is mono behavior, and this we'll use this basically to just be our interface into the light mesh. I guess this is serialized field. I'll go ahead and have those 4 different lantern sprites here. It'd be nice if we could somehow identify which quadrant each light was attached to. Maybe I should have just a square and then it'll be top left, top right. Something like that. Color should I make this? I guess it doesn't matter. Oh no, it should be white because that won't be visible on top of the actual light. Oops. Okay, so let's just start with this. So lantern quadrant. I guess let's just see what it looks like on top of these lanterns before I go any farther. Okay, we want to use our normal sprites material that has pixel perfect. And oh yeah, I'll need to set this up. I really wish I say this every stream, I know, but I wish you could set the defaults here. Oh right, I was wondering why it's not showing up here, and that's because I need to set the layer to visible. Okay, so order, this will be, let's put this on top, and then the quadrant just below. And then the actual light will be... Oh, I thought I had a way to set the... Oh, there is one, but I didn't make a variable that I could figure out, that I could set it myself. For some reason mesh renders you can't set the sorting order yourself. I mean in Unity, and you have to do it through a separate script instead of the editor, is what I'm trying to say. Which is a little annoying, but I guess they have their reasons. So the sorting order is actually 0. Okay, well that'll do for now. Okay, so we'll have the lantern colors, serialized field, private, sprite, quadrant, sprites. Oops, that's not how you spell sprite. This should actually be color sprites, I guess. I know I was gonna set like the channel select colors, but I can just do that myself in code. Okay, so get component, sprite renderer. Oh no, this is gonna be a little messy to do it that way. So this will be the color sprite renderer. And we'll also have a reference here to the quadrant sprite renderer. Actually, can't just do it here in the start. We're gonna need to be past our index. And basically the colors will, the channels will change each index, so that we'll do index mod 4, because there's 4 color channels, and then the quadrants will change every 4 index, so that'd be index divided by 4. Okay, and then I'll also need, oops, I need to change this, not start, it needs to be called somewhere else. Then I'll have the light mesh creator. That's not the render actually. I don't know if I need to have a reference to it, but just in case. And I'm doing this because I need to set, I guess I should do this in a function now. Okay, so set channel select. Okay, well, I'll come back to that. Let's generate this method. And yeah, instead of setting the colors right there, we'll set them here. Oh, I don't keep a reference to the mesh. Probably shouldn't do this in the start now either. Oops, forgot the void. So now here I'll just call that light mesh setup. Okay, so red needs to be when index modulo 4 equals 0. We return 1. That's probably a better way to do this. So the color index is this index mod 4. We'll use that there. So now I don't have to mod 4 every time. So now if the color index is 1, then green will be 1. Otherwise it's 0. Same for blue, and finally alpha. Okay, so I think this is all set up now. 1 second, I need to blow my nose. Okay, so I need to call this function somewhere. Probably the light mask manager will do that. Although for now the lights data only keeps a transform. So now we'll just have a lantern, and I guess we'll also, I don't really need to set it here, but in the light mask manager we'll need to have a reference. Okay, this is getting a little bit too big, isn't it? Okay, let's have a separate object that will create the lanterns for us. Actually, I might just make it a normal sprite, or a normal. Oh no, I guess it should be a mono behavior, so I can set some things on it in the editor. It's gotta be public. Okay, but again, I won't use the start function. Oh, I keep doing that. I don't know why I keep forgetting to type void here. So in the editor we'll have the lantern prefab here. And we'll also need to get a reference to the lights data, but I guess I don't have to have an instance variable, just private variable right here, or local variable. Okay, so how many? I guess I'll just do something like this, so private. Well, I was gonna say I'll just say num quadrants, but actually sometime we'll need to test what'll happen if there's not a light active for each possible spot. So we probably would want to be able to just say exactly how many lights we want here. So so lantern equals so we gotta instantiate the prefab. And then we'll just get the lantern object off of it. We'll call lantern. No, except this actually. Oh, I made it private. So index I, and then I just need to add this basically to the data lights list. And oh, I need to set its position. So I don't really want them all to be stacked on top of each other. I guess I'll just give it a random position in the screen. Yeah, that should be fine. So lantern transform position equals new. So this would just be, I don't know, something. 20 times random value, and this. Oh right, it's using this C# random, which I don't want actually. Okay, so this will give me a value between 0 and 1, so I need to subtract by 10 to get something from -10 to 10. Similarly, 15. value minus 7.5. Okay, so this will just place it somewhere on the screen. And I don't mind that those values are hard-coded. This is just for testing. Okay, so the light mask manager, I guess we'll set this all up first. Oh yeah. Okay, so we need to have a texture for each light, or do we? I'm not exactly sure how we'll end up combining all of them into one texture, because I know there is an upper limit on the number of textures you can put in the use in one shader, but you can kind of get around it by doing something called a sub shader. Like we have this pass, and we could have one pass to do the top corner and so forth. I think each one can have like 16 textures, so we need, I think that'd be fine, but I think you can actually have unlimited textures up in the properties. So it might work with one shader. It'll be kind of a pain because we'll have to have one texture here for each light, which might not be a great idea because, I mean, the graphics card's gonna have to load all those textures at once. And even though 128 by 128 is really small, it will add up. So it might be better if then we'd have to do a lot more graphics blitz, but we saw that that's really fast. Okay, well I guess I'm getting ahead of myself. We'll figure that out when we get to it. But yeah, so we'll just have 4 textures here for now. And what I wanted to do is get component lantern creator dot create. Okay, so now I think should be ready, although I need to finish setting up this, don't I? Okay, so why does it not have everything? Maybe because this is not letting it compile. That should fix that problem. Okay, yeah, there they all show up. Okay, so now we need to make the other lanterns, our quadrant sprites. So quadrant 2. Oops, oh, why did I do that? And 4. I think that's how we'll do it. So right now we'll have 16 lights. I'm not really sure what the maximum number of lights I'd want. I guess if we extended it to 8. So if we did one more thing out, what would it be? That'd be 16 times 4. Oh, I can't do math right now. That's 64 lights. Wait, that can't be right. No, I guess it is, okay. Yeah, okay, so this is because we have 16 lights here, so if I multiplied that by 4, we get 64, okay. So that's pretty good, actually. That might be enough for us, and if it's just 64 lights, and every light is just 128 by 128, then maybe we can do it all in one shader. Alright, so now I just need to set up this prefab. Okay, so we'll have 4 of each of these. And colors are red, green, blue, alpha, and then the 4 quadrants go in here. And the color sprite is actually this one that's right here, and then the quadrant. Okay, so now if I apply the prefab, that should all be set up. And then in the system, I guess I can delete these other lanterns now. Okay, so I'll just set this to 0 for now, and then I need to create the lantern creator, or add the lantern creator here. I'll have 16, and I need to set the prefab, which is right here. So now if I press play, will it work like before? Except only some of the lanterns will actually do anything. I think only the first 4. So this is a red. Yeah, so if I tried to pick just some random one, yeah, it's just copying what the other, or the first red lantern does, because everything is just using this one texture. I guess I should rename them to be a little more descriptive, just to help me pick them out. We can actually do it in the lantern script itself. Actually, I can even do this part in the lantern script itself. Why not? Okay, and then I want to set my name to string format. Okay, so I'm gonna be lazy here and just create. Oh no, we don't need to do that. Don't need to be that lazy. Private static string color names equals new. Okay, so red, green, blue, alpha. I'll do the same thing for quadrants. Well, I guess the quadrants could really just be a number. So index 4. Well, I guess I should use this color I. Quadrant I equals index divided by 4. I'm gonna use it twice, might as well only. Oh, I left that modulo in, no reason to do that. Okay, so now we should have better names on the game objects. Or on the lanterns that we create. Yeah, so red 0. So we can see that all the green lanterns. Oh no. The green lantern wasn't getting. Why has the mask stopped working? It just worked a second ago. What's going on here? Okay, so the mesh is still being set, but nothing is changing on the texture. What did I do? Oh. Okay. That was weird, but it seems to be working fine now. Hopefully that's not a recurring problem, because that'll be a pain to fix if I can't reproduce it. But anyway. Okay, so now we have a bunch of lights. So how do I want to try doing everything in one shader at once, or do I want to do one blit for each quadrant and then combine those together? Let's try the one big shader first, actually. So another unlit shader, and this, let's just call this so we have 4 text to 1, so I'll just call this combined 16. And okay, let's close everything. It's starting to get too much up there. So what I was reading before, there is a maximum to the number of textures you can have up. This person wants to have 205 textures, quite a bit. If you want to add to the unknown, yeah, that's fine. This is kind of old, but it says that the number of texture samplers is 16, actually. So for now, we might be able to get away with just one pass. I guess that's fine. So I'm trying to figure out. Fortunately, with the blit, there's no way we can get any other app data, so I'm trying to figure out how we know. Well, I guess we know just if a pixel is in the first quadrant, or if a UV is in the first quadrant, then we would take from the first 4 textures and so on. So let's change this up. Okay, so now the main text, we won't use that. And this will be experimental. I've never tried to do anything like this before. Finally, for the final quadrant, okay, that's just the first part, so I've got to create, I wonder, can I just get rid of these STs, because I'm not going to use them, and that would save me a lot of typing. It might complain to me. Okay, yeah, so apparently it needs them for some reason right here, even though it doesn't even call them. Okay, so I've got to change this to 0. Oh, I guess I should get all of them. So change this to red text 1. Oh gosh, I should go from the bottom up because that helping thing is going to get in my way. And finally, third quadrant, or I guess the fourth, but 3 and array indexes. Okay, so this stays the same because everything has the same UV, so we really only need to get the UV from the main texture. This part, so again, if statements are bad in textures, so I need to figure out some way to return a 0, or basically to only sample a texture we need, and that might not be, well no, it's gotta be possible. We'll just sample all textures and then discard the ones we don't need. Which seems wasteful, but I think it's actually faster than having an if statement. I guess we could test that. Okay, but yeah, for now I'll be bad and just use an if statement. So if I.uv x is less than 0.5. I'm not sure if that's right. I've never... You're not supposed to use if statements in the shader, so I'm not sure if that's the right syntax. If that's the case, then we need to transform this UV, basically lerp between 0 and 5, and I think that there is a lerp function. I don't know the syntax or the arguments. So basically, we need to transform this. Well, I guess I could just multiply it by 2, can't I? So I don't really need to use a lerp. I.uv times 2. And then we'll just use this UV instead of what's passed in. And let me see if that's throwing any errors. Cannot convert from float 2 to half-4 at line 100. Oh, yeah. Nuclear identifier green texture. Oh, okay. That. Although now I'll complain that there's no return, but let's just do something like that. I don't know how you do else. Okay, so that seems fine. Okay, so that's quadrant 1. Quadrant 2 will be if x is greater than or equal to 1/2 and y is less than 1/2. So here it would be how did I do this? Fix 2, so I.uv.x minus 1/2 times 2, because we got to subtract 1/2 from the x coordinate but not the y coordinate. The y coordinate we just gotta multiply by 2. And then, so here we'd use all the 1 texture, so red texture 1, green texture 1. Okay, so I think that's good. I guess I should check. No syntax errors. So the third quadrant is, so x second is less than half, but y is greater than or equal to half. And then we kind of flip how this works. And then we use the second or third textures. And finally, now we invert, or we gotta subtract 1/2 from both sides. And we use the third textures. Okay, and again, this will work, but any shader writer will cringe at using if statements. It's gonna, I mean, it really gets rid of most of the optimizations that the GPU does. But I just want to try and get this working. Which unfortunately we're out of time, so I won't really be able to test it. But yeah, we'll do that next time. And hopefully this will work, and then we'll try to figure out a way to do this without if statements, which, I don't know, this might be one good time to actually use an if statement because it will prevent us from having to to sample each texture on every single pixel. But I don't know if that's actually faster than having to do these if statements. It's kind of, GPUs are kind of weird like that. So yeah, we'll test that. And then, again, we're at according to this forum post, we're at the maximum number of shaders that you can reference in one pass, which is 16. So, maximum amount of textures. So, I want to support at least 64 lights, and in that case, we need to do multiple passes. Which will kind of be a pain because we're just going to copy and paste this pass 4 times and then change these numbers around. But writing shaders in general is not the most, what's the word? Requires quite a bit of busy work. But I think we did make some progress, and I'm glad that we figured out how to move the textures into a smaller spot on the screen, so that's good. But anyway, thanks everybody for coming by and watching. I really do appreciate it. Like I said, tomorrow we'll continue on this, and I should be here by about 8:30 Eastern. If you want to catch up on this stream or any other past ones, I upload them all to my YouTube channel, which you can find either in my channel description or by typing !YouTube in chat. I also have a Discord channel if you'd like to chat with me and other viewers. Again, it's pretty small right now, so if you have any interest, I'd really appreciate anybody coming by. You can get there !Discord in chat or in this video or my channel description. And again, thanks everybody for coming by. I hope you have a great night, and see you tomorrow. Bye bye.